Welcome back again to Algebra 2. Today's lesson is 6.2, Solving Quadratic Equations Using the Zero Product Law. Now, there's very little in this lesson that is new. Most of it is left over or, just a repeat lesson of what we learned in Algebra 1. But again, with geometry falling between it, I always think it's a good idea to revisit. So, in exercise 1, well, first of all, zero product law is if the product of multiple factors is equal to 0, then at least one of these factors must be equal to 0. So, for example, in exercise 1, solve each of the following equations for all value or values of x. And this is already factored form for you. So, when you have a situation like this one, I know that x is going to equal 0, x plus 7 is going to equal 0, or x minus 3 is equal to 0. And just solve these for zeros. Well, this one's already solved for 0. Minus 7 from both sides. So this is x is equal to negative 7. And add 3 to both sides. And this is x is equal to positive 3. So it's really easy when it's already in factored form, but of course you know that that will never be the case. So moving on to B. We set each of our products equal to 0, so 2x minus 5 is equal to 0, and x minus 4 is equal to 0. Don't flip out that this is a fraction. You can handle it. 2x is equal to 5. Divide both sides by 2, and x is equal to 5 halves. Or add 4 to both sides, and x is equal to 4. All right, well, in this last one, you can see how that we have an integer out front, that's 4. Well, we can't set 4 equal to 0 because 4 is 4. Don't give it an identity crisis, okay? You can't set 4 equal to 0. So if there's an integer, just cross that out. It's one that we can't set equal to 0. Anything with a variable, we can set equal to 0. So 4x minus 3 is equal to 0. You should be able to do this very easily. Equals negative 2, divide both sides by 3, and x is equal to negative 2/3. Or add 3 to both sides. 4x is equal to 3, divide both sides by 4, x is equal to 3/4. Again, with some of these questions, do me a favor and just watch it, and then pause it and write it down. Because if you're trying to write it down and listen at the same time, it really doesn't, it won't help you. You're really better off watching it, pause, and then write it all down. All right, so the zero product law can be used to solve any quadratic equation that is factorable. All right, to utilize this technique, the problem solver must first set the equation equal to 0 and then factor the non-zero side. All right, so if you take a look at exercise 2, you'll see how we have a quadratic here. We know it's a quadratic because our degree of the equation is degree 2. That tells me that the highest exponent is a 2. So the first thing we're going to do is we're going to set this equal to 0. Now you can do this in 2 steps or you can do it in 1. For example, you could, now don't write down yet, you can add 2x to both sides. And you get x squared plus 5x minus 14 is equal to 10. Then you can minus 10 from both sides. So you get x squared plus 5x minus 24 is equal to 0. All right, so I just did that in 2 steps. If you wanted to, you could kind of skip the second step, and you can do this in 2 steps. Minus 10, minus 10, and then when you do that, you would skip right down to this one. So whatever way works for you, that's the way I want you to do it. If you're not comfortable with skipping steps or combining steps, then do it the long way. No judgment, really. All right, so now in this case, we have this beautiful quadratic now, and this is factorable. So we have x in the first position. We know the signs are different, so we have a plus and a minus. We're looking for 2 numbers that multiply to 24, but subtract to give me 5. And we need to be a positive 5, so the 8 times 3 that this is, and quickly I'm going to just check it. Positive 8 times negative 3 is a negative 24, and positive 8 plus a negative 3 is a positive 5. So I just take that moment and just give it a quick check, And now I'm going to set each of them equal to 0 using my product law. So x is equal to -8, or x is equal to 3. So exactly what I just said with A, if you're comfortable, this is a three-stepper. So you can say minus x squared minus 3x plus 2, which makes everything on this side go to 0. And do the same thing here, minus x squared minus 3x plus 2. So what do I end up getting here is 2x squared plus 9x minus 5 is equal to 0. And now we factor this. Now you can use the rectangle if need be, but with a prime number like 2 and 5, I think you're pretty okay with just using a little guess and check. Because remember, I need this one and this one to subtract to give me 9. So it kind of makes sense to me to put the 5 here and the 1 here. So I need this product to be positive, this product to be negative. So I get a negative 1x and a positive 10x, which does add to give me a positive 9x, which is what I needed here. And now set each of them equal to 0. So 2x minus 1 equals 0. X plus 5 is equal to 0. Add 1 to both sides. 2x is equal to 1. Divide both sides by 2. And x is equal to 1/2, or 0.5 if you prefer. Minus 5 from both sides. And x is equal to negative 5. Now again, I kind of did that fast, but I'm expecting that you're going to watch it, pause it, and then write it down. All right, moving on to exercise 3. Consider the system of equations shown below consisting of a parabola and a line. All right, so I know this is a quadratic, which yields a parabola, and I know this is a line because it's y equals mx plus b form. It says find the intersection points of these curves algebraically. So now curves, not really a curve for a line, but these functions anyway. So algebraically, we're looking for intersection points, and there could be a few of them. All right, so just to give you an idea, we could have something that looks like this with 2 points. We could have something that looks like this with 1 point. And technically, we could have something that looks like this with no points. So we have to find out which one of these it is. So we do that by solving for x and see if we have any x values that solves the equation. Now to do this algebraically, both of these are equal to y. So I can simply take these two and set them equal to each other. So I have y equals here, y equals here, so I can take this piece and set it equal to this piece. So you get 3x squared minus 8x plus 5 is equal to 4x minus 5. Looks very similar to some of the problems we did on the previous page. We're going to minus 4x plus 5 minus 4x plus 5. So these go to 0. And I get 3x squared minus 12x plus 10 is equal to 0. I know there's not an awful lot of room here, so I'm sorry about this. So make sure when you're writing this all the way over to the left, because we might have to go into where that graph is. So we're going to factor this. Now I see a 3 and a 12. I get all excited thinking I can pull a 3 out, but the 10 doesn't go in evenly into 3, so I can't. So I have to move right into factoring. So obviously I'm going to have 3x and I'm going to have x. And again, I need those factors to multiply to 12. Multiply to 10, but they have to add to give me 12. So let's see, 10, 5, 12. So if I put a 5, okay, sorry for that interruption. But I'm hoping you're kind of going crazy on me right now because I just saw a mistake as I was waiting. So my apologies, because by accident, this was a positive 5. So when I minus 5 from both sides, these cancel out. So my apologies. Here I go again. All right. So here we are. So it's this is equal to 0, which makes this a whole lot easier. So, sorry about that. So now we can factor out the greatest common factor. So now I can take a 3x out of this and get x minus 4 is equal to 0. Set each of these equal to 0, so I have 3x is equal to 0. So divide both sides by 3 and x is equal to 0. And I get x minus 4 is equal to 0. Add 4 to both sides, and x equals positive 4. So this is actually going to have 2 points, because I have 2 x's here. That will work. Now beware, don't think you're done, because these are just the x values. We need to go back and find the y values. Now I'm going to pick the easier function, which is basically the y equals 4x plus 5. All right, so now I'm going to set x equal to 0. So I get y is equal to 0 plus 5. So y is equal to 5. So this point is going to be x is 0, y is 5. Now I'm going to do the same thing with my other one with x equals 4, because I just got these right from here. X is 4 and x is 0. So y is equal to 4 times 4 plus 5, which is equal to 16 plus 5, which is equal to 21. So my point is going to be 4, comma, 21. So these two are the answers to the solution now. So we have this one and we have this one. So if you consider what this would look like on our graph, we would have something that looks like this, and 0, 5, 0, 5, 0, 5, and 421. So this is what it would look like if we just sketched it out. Not really important to sketch it, just wanted you to have an idea of what it looked like. Okay, well, moving on to exercise 4. Oh, this says verify your answers using your calculator, which you can't do, but we can try it tomorrow when you get into class. So the zero product law is extremely important in finding the zeros or the x-intercepts, the zeros of the parabola. So exercise 4 says the parabola shown at the right has the equation y equals x squared minus 2x minus 3. Write the coordinates of the two x-intercepts. Now beware of this. This says write the coordinates. Usually if they ask for the x-intercepts, they just want the numbers. So they want the numbers -1 and +3. But they're asking for the coordinates. So the coordinates are going to be -1, comma 0 and 3, comma 0. Find the x-intercepts of the parabola algebraically. Well, algebraically means we have to do this by factoring, which we know everybody loves to do. So you have x minus 3 and +1. So there we come out with equals 0. So then we'd have x minus 3 equals 0, which gives us our +3. We have x minus 1. X plus 1 is equal to 0, which gives us our -1. So it goes to show you that you can find your zeros by looking at your graph or doing it algebraically, especially if they can factor. So the last one is exercise 5. Algebraically, find the set of x-intercepts, or the zeros, for each of the parabolas given below. So why don't you pause this and try doing this on your own, and then I'll snap to the answers, okay? There we go. So why don't you take a minute, compare your answers to these answers, and if you have any questions, bring them into class next time. Okay, so if you've been instructed to finish the independent practice, get started on it. If not, then you can get working on it in class at the next time. Okay, so until next time, what do I always say, Janae? Make good choices. Comments, questions, concerns are going to be for class, because unfortunately I can't answer questions on the video. I'd like to be able to do that. When I can do an interactive video, you're the first one I'm going to tell.